video, we're going to look at adding and subtracting complex number geometrically and kind of graphically. So we're going to be given two different values, and they're pretty simple to just add them. You add the real and the complex, but we're going to look at this as a parallelogram geometrically. So if I'm given -3 plus 5i, I'm going to add this to 5 plus I. What I'm going to do first is I'm going to start with the points. So I'm going to start with this guy right here in this dark blue. So I'm going to go back 3. Each box it represents 1 unit. So go back 3, 1, 2, 3, and up 5. 1, 2, 3, 4, 5. Alright, and then I'm going to do the same. I'm going to change colors though. I'm going to go over 5. 1, 2, 3, 4, 5, down 1. Now I'm going to use the origin kind of as a place for my parallelogram so that I could log my legs there. So this origin here first is that one. 1, 2, 3, 4. 1, 2, 3, 4, 5, and 1. Okay, yes. Oh, up 1. I go down 1. I was like, that's not 1. Up 1. Up 1 here. 1, 2, 3, 4, 5. Stop 1 here. Sorry about that, guys. In my mind, I went down up 1, and for some reason, when I drew it out, I went down 1. So it goes there. We make our way. We'll put this first point here so that when I move that, I have that there. And the second one is over here. Alright, so now looking at this, we're doing a parallelogram, so I have to also have the distance the same from this one. So this pink point, again, trying to make my parallelogram the same going up here. We're going to pivot that here. And we're going to do the length of that pink point and the angle. So this is going to be 1, 2, 3, 4, 5, up 1 here. Up 1 there. That's weird to see. And then the blue point should go down so we get this nice parallelogram. And what we're left with here is the point. Is the point here. 1, 2, and 1, 2, 3, 4, 5, 6. Now if I were to take this and add algebraically, again this is 2 plus 6i. If I were to add this algebraically, we have -3 plus -3 abney plus 5 plus 5 plus 1i. And we would be left with 2 plus 6i, which is where we end up here. Alright, so the fourth point in this parallelogram is located at 2, 6, which represents the complex number. I'm having a hard time today. 2 plus 6i. And this is the same result you would get from adding them together. Okay, so let's use the parallelogram to subtract. Grab a new complex chart in here. You're going to see a little bit of me trying to add the image in. Make this big. Move it over. I'm actually going to use a different layer, which I should have done last example. Alright, so we have the numbers -3 plus 5. I'm going to be like, Miss Abney, this is what we already had, but we're subtracting these two instead. Okay, so we're going to plot the points. First, I'm going to use the maroon for the 3, 5i. So 1, 2, 3, each unit represents 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then this one is going to be 5 plus I. And we're, oh wait, let me know what. Let me draw these lines first here to the origin. All right, and then make sure that this is on the origin there. And then 5 plus I, I'm going to use this one as blue. 1, 2, 3, 4, 5, and this time I'm going to go up 1 like I was supposed to last time, but failed to do. Draw my line going to there. I went a little bit further, so let's erase that little bit. All right. So what I'm going to do now is I'm going to find the opposite of 5 plus 1, because this right here says we're finding the opposite. Do that in green. So the opposite of this is negative 5. 1, 2, 3, negative 1. Oh, I said green and then I choose orange. And so we're looking at this line continuing on. And now we're going to draw the parallelogram from the orange and the red. And the whole reason we did the opposite here is because of that negative. That's the whole reason we have that negative there. All right. So now my parallelogram off of this would be, move this up. And I'm going to go 1, 2, 3, 4, 5 over. 1, 2, 3, 4, 5 over. And put this in orange actually. Move that point there. Swing this guy around. Move that down there. So this, remember, this piece is the negative part of our equation. So we just kind of flipped it. And what we are left with here is this point, which is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Comma. 1, 2, 3, 4. So my new equation, my new points, my new expression when I combine these would be 8 plus 4i. Now if I were to just do that algebraically, I have negative 3. This negative gets distributed to negative 5. And then plus 5 minus 1i. And we get 8. 5 minus 1 is 4 plus 4i. And we see that graphically in that parallelogram. Alright guys, so this is adding and subtracting complex numbers geometrically, and I know it's kind of fun to do. It's kind of fun to see how this looks like on the graph using those parallelograms, using that distance, especially the distance from the origin. And remember to always use your origin here. Your origin is like your anchor. I wish I could draw an anchor. Maybe I could draw an anchor. Let's see. Oh, I forgot what anchors look like. Okay, that is just pi. So just pretend like it's your anchor. And let's pretend like that anchor looks really good. But again, this is your origin. And so use that for your parallelogram. So if you want to do this graphically, and this doesn't show up too often, but it can show up, and this is a great method to try to solve these types of problems if you're given it graphically. You know, instead of pointing it out and just making it into an equation. But whichever way is easier, and whichever way the question is asking you to do it would be best. Again, if you have any questions, please always feel free to ask it. I will catch you in the next video.